In 1997, the National Oceanic and Atmospheric Administration picked up a sound so loud it was detected by sensors more than 5,000 kilometers apart. It came from somewhere deep beneath the Pacific Ocean. It didn't match any known animal. It didn't match any known geological event. And to this day, no one can say with certainty what made it. The ocean covers 71% of our planet. We've mapped more of the surface of Mars than we have our own ocean floor. And down there, in the crushing black silence, things exist that challenge everything we think we know. Tonight, we dive into 3 of them. Humans have been explorers for thousands of years. We've climbed the highest mountains, crossed the harshest deserts, and sent machines beyond the edge of our solar system. But the deepest parts of our own ocean remain almost entirely unknown. Less than 5% of the world's oceans have been explored in any meaningful detail. That means 95% of an entire world sits in darkness, untouched, unseen, and unstudied. In this video, you're going to discover 3 genuine underwater mysteries that have baffled marine scientists, oceanographers, and military analysts for decades. These aren't myths. These aren't legends exaggerated by time. These are real, documented phenomena, captured by instruments, witnessed by professionals, and verified by institutions, that still, as of today, have no definitive explanation. Some of them are eerie, some of them are awe-inspiring, and one of them might fundamentally change what we understand about life on Earth. Let's begin. Our first mystery begins not with what was seen, but with what was heard. The year was 1997. The Cold War had ended just a few years earlier, and the United States government was quietly repurposing a vast network of underwater listening devices. These hydrophones, originally designed to track Soviet submarines, were now being used by NOAA for something entirely different: listening to the ocean itself. These sensors were part of a system so sensitive that they could detect the faintest rumble of an underwater volcano from thousands of miles away. They could pick up the songs of blue whales migrating across entire ocean basins. They were, in a very real sense, humanity's ears pressed against the deepest floor of the planet. And on a summer day in 1997, they heard something no one expected. The sound was ultra-low frequency, which means it was far below the range of human hearing. When researchers sped it up to make it audible, what they heard was a rapid, rising, blooping noise, which is how it got its name, the bloop. Now, what made this remarkable wasn't just its strangeness, it was its power. The bloop was, according to NOAA's own calculations, one of the loudest underwater sounds ever recorded. It was detected by multiple hydrophone arrays spread across the Pacific Ocean, sensors that were more than 5,000 kilometers apart. To put that in perspective, a blue whale, the largest animal that is known to have ever existed on Earth, produces calls that can be detected across hundreds of miles. The bloop dwarfed them. Naturally, the first question scientists asked was, could it be biological? Could there be an animal in the deep ocean, something we've never seen, capable of producing a sound this powerful? The profile of the sound, its rise in frequency, its duration, did share certain characteristics with biological calls. Marine biologists noted similarities to the vocalizations of large marine animals. But there was a devastating problem with that theory. For any living creature to produce a sound this loud, it would have to be enormously larger than a blue whale. We're talking about something on a scale that, according to our current understanding of biology, simply should not exist. The physics of biology impose limits. Cells need oxygen. Muscles need energy. No known biological framework supports a creature of that magnitude. So if it wasn't alive, what was it? NOAA eventually offered an explanation in 2012, 15 years after the original detection. They suggested the sound was consistent with a large ice quake, the cracking and fracturing of massive Antarctic ice shelves. The location of the bloop's origin, in the remote southern Pacific, was roughly consistent with this theory. Ice, when it breaks apart on a massive scale, can produce ultra-low frequency sounds that travel enormous distances underwater. Case closed? Not quite. A significant number of oceanographers and acoustic analysts have pushed back on this explanation. Some have pointed out that while ice quakes are common and well documented, the acoustic profile of the bloop doesn't perfectly match known ice quake signatures. Others have noted that the single distinct nature of the event, one powerful sound, never repeated at that magnitude, is unusual for glacial activity, which tends to produce clusters of events. And then there's the uncomfortable truth that sits at the center of this mystery. We've explored less than 5% of the deep ocean. We have cataloged only a fraction of the species that live down there. In 2012 alone, the very same year NOAA offered their icequake explanation, marine biologists discovered more than a dozen new deep-sea species. In the years since, the discoveries have only accelerated. Giant squid, once thought to be myth, were only filmed alive for the first time in 2004. New species of deep-sea fish, coral, and invertebrate continue to appear almost monthly. So when someone asks, could there be something down there we haven't found? The honest scientific answer is almost certainly yes. The question is whether that something could be large enough, powerful enough, and strange enough to produce a sound like the bloop. And that no one can answer. Now, if an unexplained sound from the deep ocean is unsettling, what we're about to explore next goes even further. Because our second mystery isn't just something we heard, it's something we found. Something that shouldn't exist where it was found. Something that, depending on which scientist you ask, either rewrites a chapter of Earth's history or opens a door to a chapter we didn't know existed. In June of 2011, a Swedish ocean exploration team called Ocean X was conducting a routine sonar sweep of the floor of the Baltic Sea. The team, led by divers Peter Lindberg and Dennis Osberg, specialized in locating shipwrecks and salvageable cargo, a common and often lucrative profession in the Baltic, one of the most heavily trafficked seas in human history. Their sonar equipment was good, but not extraordinary. It was the kind of side-scan sonar used by dozens of similar operations around the world. They weren't looking for anything unusual. They were looking for old ships and the valuables inside them. What they found instead was a shape on the ocean floor that stopped them cold. At a depth of approximately 85 meters, sitting on the seabed in the northern Baltic Sea was a massive, roughly circular object, approximately 60 meters in diameter. That's nearly 200 feet across. Surrounding it on the sonar image was what appeared to be a long track or trail, as if the object had skidded or been dragged across the ocean floor before coming to rest. The initial sonar image was grainy, ambiguous, and open to interpretation, but its shape was striking. To many who saw it, the object bore an uncanny resemblance to the Millennium Falcon from Star Wars, a disc-like shape with irregular edges and what appeared to be structural features on its surface. The internet went into a frenzy. Headlines exploded. UFO found at the bottom of the Baltic Sea. The story was picked up by media outlets around the world. But the scientific community cautioned patience. In 2012, Ocean X returned with better equipment and a dive team. What they found only deepened the mystery. Divers reported that the object appeared to have distinct features: right angles, walls, corridors-like formations, and what some described as a staircase-like structure. The surface, they said, felt unlike natural rock. Some team members reported that their electronic equipment malfunctioned in the vicinity of the object. Geologists weighed in. Some suggested the object was a glacial deposit, a chunk of rock and sediment left behind by retreating ice sheets at the end of the last ice age, roughly 10,000 to 12,000 years ago. The Baltic Sea's geological history is complex. It was once covered by a massive glacier, and as that glacier retreated, it deposited all manner of debris on the seabed. Unusual rock formations in the Baltic are not uncommon. But that explanation didn't satisfy everyone. Volker Bruchert, an associate professor of geology at Stockholm University, analyzed samples reportedly taken from the object and stated that the mineral composition was unusual, including materials that would not typically be found in that geological context. Others pointed out that glacial deposits, while common, rarely produce the kind of geometric regularity that divers described. An independent analysis by Israeli geologist Steve Weiner reportedly concluded that the samples contained metals and what he described as burned materials, limonite and goethite, which are iron oxides, as well as traces of actual metals that are not naturally formed on the sea floor. Now, it's important to state clearly, no peer-reviewed scientific paper has conclusively established that the Baltic Sea Anomaly is anything other than a natural geological formation. The scientific consensus, to the extent one exists, leans toward a natural explanation: glacial activity, unusual mineral deposits, or volcanic rock. But leans toward is not has proven. And the frustrating truth is that no comprehensive, large-scale scientific study has ever been conducted on the object. Funding has been limited, interest from established academic institutions has been minimal. The object sits in cold, murky water in a region where diving conditions are difficult and expensive. What we're left with is a gap between what was found, what was reported, what was sampled, and what has been conclusively explained. And in that gap, the anomaly sits, 60 meters across, 85 meters deep, on the floor of one of Europe's busiest seas, waiting. Is it a glacial rock shaped by 10,000 years of currents? Possibly. Is it a volcanic formation from a geological epoch we don't fully understand? Maybe. Is it something else entirely? Something that challenges the neat boundaries of our geological or even our historical understanding? That question remains unanswered. And until a serious, well-funded scientific expedition descends to the floor of the Baltic Sea with modern equipment and a mandate to study this object thoroughly, it will stay that way. 2 mysteries in, and we've already confronted a sound that defies easy explanation and an object that no one has adequately studied. But what if I told you that the 3rd mystery on our list is by far the strangest? Because this one doesn't involve sounds or shapes. It involves light, an actual, visible, underwater phenomenon that has been documented by navies, satellites, and sailors for over 400 years. And science still cannot fully explain what causes it. Imagine you're standing on the deck of a cargo ship in the middle of the Indian Ocean. It's a moonless night. The air is warm and still. And then, without warning, the sea around you begins to glow. Not the faint, occasional shimmer of bioluminescence, the kind you might see when a wave breaks on a warm beach, or when your hand disturbs the surface of a tide pool at night. This is different. This is the entire ocean, from horizon to horizon, glowing with a steady, pale, milky white light. Not flickering, not pulsing, glowing uniformly, as if someone had switched on a light beneath the entire surface of the sea. This is what sailors call a Milky Sea, and it has been documented for centuries. The earliest known written account dates to the 1600s. Sailors in the Indian Ocean and the waters around Indonesia described nights when the sea turned a ghostly white, stretching as far as the eye could see. For centuries, these accounts were dismissed as exaggerations or hallucinations, the products of long voyages, isolation, and superstition. But in 1995, a British merchant vessel called the SS Lima documented a Milky Sea event in such rigorous detail that it could no longer be ignored. The crew reported that the ship sailed through a uniformly glowing ocean for approximately 6 hours. The glow was bright enough to read by. It extended to the horizon in every direction, and it was utterly silent. No unusual waves, no change in water temperature, no storms. In 2005, Stephen Miller, a researcher at the Naval Research Laboratory in Monterey, California, achieved a breakthrough. Using archived data from the Defense Meteorological Satellite Program, military satellites that carry low-light imaging sensors, Miller identified a Milky Sea event in the northwestern Indian Ocean from 1995. The satellite imagery showed a glowing patch of ocean roughly 15,400 square kilometers in size. That's an area larger than the state of Connecticut. It persisted for 3 consecutive nights. This was the first time a Milky Sea had ever been confirmed from space, and it raised far more questions than it answered. The leading hypothesis involves bioluminescent bacteria, specifically a strain known as Vibrio harvei. These bacteria are known to produce light through a process called quorum sensing. When enough individual bacteria accumulate in one area and reach a critical population density, they simultaneously activate their bioluminescent chemistry. The result is a coordinated collective glow. Sounds reasonable, but the math is staggering. To produce a uniformly glowing area of ocean the size observed by satellite, 15,400 square kilometers, you would need an almost inconceivable number of bacteria. Scientists have estimated the required concentration at approximately 40 billion bioluminescent cells per liter of seawater, spread across an area larger than many countries. That is a bacterial bloom of a scale that is, frankly, difficult to reconcile with our understanding of marine microbiology. What could cause such an event? Some researchers have hypothesized that Milky Seas might be linked to unusual algal blooms. When a massive phytoplankton bloom dies off, the decaying organic matter could provide a sudden, vast food source for Vibrio harvei, allowing the bacterial population to explode to the required densities. This would explain why Milky Seas are most commonly observed in the Indian Ocean and the waters near Indonesia, regions known for intense biological productivity. But there are problems with this model too. Not every algal bloom leads to a Milky Sea. In fact, Milky Seas are extraordinarily rare, perhaps only a handful of confirmed events per decade. If the trigger were simply a dying algal bloom, we'd expect them to be far more common. Something else is happening, some additional factor, some specific combination of conditions that science has not yet identified. And then there are the characteristics of the glow itself. Bioluminescence in the ocean is almost always triggered by mechanical disturbance, movement, waves, the passage of a ship's hull through water. But Milky Seas glow uniformly, without disturbance. The light is steady, not reactive. The sea doesn't light up when you touch it. It's already lit. This is fundamentally different from any other known form of marine bioluminescence, and it suggests a mechanism that we don't fully understand. There's also the duration. Most bioluminescent events in the ocean last seconds, maybe minutes. Milky Seas persist for hours, sometimes nights. The 1995 event lasted for 3 consecutive nights. What sustains the energy output? Bacterial bioluminescence requires chemical fuel, specifically a molecule called luciferin and an enzyme called luciferase. Maintaining a glow across tens of thousands of square kilometers for days would require an astronomical quantity of chemical energy. Where does it come from? To date, no scientific expedition has ever been present during an active Milky Sea event. Every study, every analysis has been conducted after the fact, using satellite imagery, ship logs, and water samples taken days or weeks later. No one has ever dropped instruments into a Milky Sea while it was happening. No one has taken real-time measurements of the bacterial density, the water chemistry, the dissolved oxygen levels, the nutrient concentrations. And this is perhaps the most frustrating aspect of this mystery. We know Milky Seas are real. We have satellite confirmation. We have centuries of eyewitness accounts. We have a plausible but incomplete biological hypothesis. But we've never been there when it happens. We've never seen it with scientific eyes in real time. The ocean, it seems, keeps its strangest secrets on its own schedule. Step back for a moment and consider what we've just encountered. 3 mysteries, 3 completely different phenomena. One acoustic, one structural, one visual. Spanning different oceans, different decades, different scientific disciplines. And yet, they all share something in common. They all exist in the spaces we haven't looked closely enough. The Bloop was detected by instruments designed for Cold War espionage, not ocean science. The Baltic Sea Anomaly was found by treasure hunters, not geologists. Milky Seas were confirmed by military satellites, not marine research vessels. Every single one of these discoveries was accidental. We stumbled upon them. We weren't looking. And that raises a question that should genuinely unsettle us. What else is down there that we haven't stumbled upon yet? The Mariana Trench descends to nearly 11,000 meters. The mid-ocean ridges, the longest mountain chain on Earth, stretch for over 65,000 kilometers across the ocean floor, and vast sections of them have never been surveyed. Hydrothermal vents, discovered only in 1977, revealed entire ecosystems thriving in conditions we previously thought were incompatible with life. No sunlight, extreme pressure, temperatures that would destroy most known organisms. Life, it turns out, is far more inventive, far more resilient, and far more strange than another mechanism at work that we haven't even conceived of yet. What matters is that these questions exist. What matters is that the ocean continues to surprise, to challenge, and to humble us. Because in a world where we carry the sum of human knowledge in our pockets and can see the surface of Pluto in high, we ever imagined. And we've barely begun to look. The truth is this: the ocean is not just another environment on Earth. It is, in every meaningful sense, a different world. A world with its own rules, its own physics, its own darkness. A world where sound travels faster than in air, where pressure can crush steel, where light ceases to exist beyond a few hundred meters, and where life has evolved solutions to problems we didn't even know existed. We call ourselves a spacefaring civilization. We dream of Mars, of Europa, of Titan, and yet, beneath the waves of our own planet, an alien world has been waiting, patient, silent, vast, for us to pay attention. 3 mysteries, 0 definitive answers, and that's not a failure of science. That's an invitation. Every unanswered question in the deep ocean is a door we haven't opened yet. Every anomalous signal, every unexplained structure, every impossible glow is evidence of how much we still have left to discover. The Bloop may have been ice. It may have been something else. The Baltic Sea Anomaly may be a glacial deposit. It may be more. Milky Seas may be bacterial blooms on an unimaginable scale. Or there may be a me definition. It's worth remembering that there is an entire realm on our own planet that remains, in the truest sense of the word, unknown. And perhaps that's not something to fear. Perhaps that's something to be grateful for. Because as long as the ocean holds its secrets, we will always have a reason to explore. If this journey into the deep made you think, made you wonder, or gave you chills, subscribe to this channel. We dive into the strangest, most unexplained corners of our world every single week. Hit the bell so you don't miss the next one. And if one of these 3 mysteries fascinated you more than the others, drop it in the comments. I read every single one. The next video is on screen right now. I'll see you there.